Hello everyone and welcome back to another Universe Sandbox video, and today we're going to be doing a more experimental kind of video. And what we're going to be doing is we're going to be seeing how luminous does the sun have to be to support Earth with its normal conditions in the orbits of the other planets. But before we get started on this video, guys, if you haven't already, make sure to suppress that subscribe button and the like button. Let's see if we can go for 30 likes on today's video as well, guys. And yeah, help us on the journey to 30,000 subscribers by midway through January to February. So yeah, again, guys, as always, I really appreciate all the support that you guys give on all of these videos. And yeah, hope you enjoy today's video as well. But without further ado, let's get cracking. So, first of all, we have Earth obviously in its normal orbit. So as we can see, temperature here sitting around 7 average. So that's roughly, we'll put that as our target roughly. That's where we want Earth to be in all of the other orbits that we're going to place it in. So, for instance here, Earth, we know that the normal Earth, well, all you need is one L for one luminosity. So, we obviously know that's where it needs to be for it to work. So, one luminosity of Sun will support Earth in its current position. But if we go towards the Sun, so let's go to Venus first, then we'll hop to Mercury after. So what we're going to do is we're going to replace Venus with Earth. So if we go down here, there we go. So put a new Earth in there. There we go. So this is Earth now in Venus's orbit. So we're going to see how hot does it get to begin with, and then we're going to see how much do we need to change the Sun for Earth to be or sit in its normal conditions. Because if we keep Earth here, we're going to see that temperature's going to get a little too much for Earth to handle here. So as we can see, look, that just putting it in the orbit of Venus has already caused absolutely chaotic temperatures, as we can see here. Look, 55 going, yeah, so too hot. And if we just keep it rolling, see how high it actually goes. Whoa. So okay, so sitting at 57 average. So as you could probably work out, not really the conditions we're after. So now we need to go to the Sun itself, and we need to detune the Sun's luminosity to see how much luminosity we actually need for Earth to be supported here. So, if we look at the orbit of this orbit here, roughly, so Venus is roughly, what? Yeah, 0.7 AU out. So, I'm going to have a little play of the Sun here. So, what we're going to do is we're just going to lock all these, because I don't want it all messing up when we change the luminosity. So, keep the mass locked. Okay, so, luminosity. If I put this to 0.7, enter. Okay, so that's now 0.7 suns. So as we can see, that should have changed. So, if we now press play, this Earth should start cooling down a bit. So let's just watch and slowly see as this Earth cools down. So, still cooling down. And obviously now the original Earth, that will obviously be getting very cold, since it's now too cold in that orbit. So, yeah, again, we want our target to be around, say, 10-ish. We'll try and aim for around 10 degrees, just under 10. So again, it's still not really enough. So again, we need to actually, I'm going to lower the Sun down to 0.6 luminosity. Just a little bit more. Because every number counts really in the solar system. So again, that's a dramatic change there. So let's just see how low is it actually going to go. Again, so it's still cooling down. Okay, so it's sitting around 17. Okay, so just a tad more, I think is what we need. And remember, we can only play with the Sun's luminosity. We're not allowed to change any of the other stats of the planets or anything. So there we go, 0.5 luminosity of Sun. And that hopefully will put Earth roughly where we want him. So again, let's just speed up time. And there you go. So 6, 5, 4. Oh no, it's a little too much. Okay, a little too over. So what we're going to do is 0.55. So there you go. So halfway in between 5 and 6 there at 0.55. So again, if we go back to Earth, that should give it the little kick it needs just to keep it in the 5 to 10 temperature range. So let's see, 6, 7. How high is it going to go? And there you are. That looks to be roughly, yeah, there you go. In between 5 and 10. That's roughly our target. So for Earth to be in the orbit of Venus, the Sun needs to be roughly around 0.55 luminosity. So, for this Earth, we'll put, so we can compare them all later, 0.55. Voila. So, or, yeah. 0.55 L. There you go. Cool. Right, so moving to probably the hardest of them all, and probably the dimmest the Sun's going to need to be, the orbit of Mercury. Again, this is going to be even more insane than the orbit of Venus, but remember, we have already tuned the Sun down a bit, so it won't be getting the full danger levels it was, but it's in the red zone, so either way, this Earth is not going to be enjoying its orbit for the next few minutes until we detune the sun down. So if we go all the way down here, there you go. So let's just let it run. There it is there. So as you can see, this Earth is going up to so even more insane than the orbit of Venus. So remember, this sun has already been turned down as well. So that's obviously not what we want. So for this sun, I'm guessing we're probably going to need to go to at least 0.25. I think that may be too much as well. So let's have a look. Okay, it's in the green actually. Okay, let's see. So there you are. Let's speed up. Yeah, it looks like we may have to go down a little more than that. So still 50 degrees. So again, because remember, the orbit Mercury roughly sits. I mean, that's probably an outer sort of orbit around a red dwarf star. But obviously the sun is still producing luminosity a lot more than a red dwarf. So again, we're going to need to really tune it down. So 0.15. We'll take a whole nother luminosity off there. Okay, let's see how Earth deals with that. Okay, so it's into the 30s, into the 20s, into the 19. Okay. Oh, 10 degrees. Okay, that looks to be it. All right. 9 and 10 degrees. That is where we want to be aiming. Okay. So, we had to go down to 0.15 luminosity of sun on this version here. So that is quite a big change from Venus. So, 0.15 L. So, we have Earth in its normal orbit at 1 luminosity of sun. Then, at the orbit of Venus, it has to go down by 0.45 to 0.55. And then from Venus to Mercury, we have to take another 40 off to get to, or 0.4 off, I should say, to get to Mercury's orbit. But as you can see, the Mercury orbit one, that's obviously in the good spot now. The Venus orbit, getting a bit cold. And then the original Earth orbit, very, very cold. So, there we are. But now we need to do the reverse effect. We're now going to Mars's orbit. So, replace orbit. Now we want to put Earth in here. So, Earth, there you go. Okay. Now this Earth is going to get completely frozen up straight away, as we can already see from the normal Earth orbit. So, remember, the normal Earth, you need 1 luminosity of sun. And Mars is roughly around, what's it, 1.25 sort of distance first, or 1.5. Okay, so what we're going to do is we're going to immediately, just a random gamble, I'm going to throw it to 1.4 luminosity of sun. So that will hopefully give the Earth in the Mars orbit a little kick it needs. So let's have a little look. Let's watch it. Nope, it's not enough. Still needs more than that. So as we can see, even in the orbit of Mars, it's still in the blue zone of the sun with that luminosity boost. So again, that's not good enough. We need more. So we're going to go to, okay, 2? Maybe 2? There we are. Okay, it's in the green. Okay, it's warming up a bit. Still in the minuses. No, still there. Because remember, Mars's orbit is slightly more eccentric than the other inner planets. And the same with Mercury's. Mercury's orbit is quite eccentric as well. But yeah, Mars's orbit is especially, as you can see, it has to have quite a wild temperature change there. But again, it's just not enough to really get Earth into the positive temperature. So let's go over 2.1 luminosity of sun. Let's see if that gives it the kick it needs. No. Ooh, it's almost breaking into the zeros. But again, it has that very, or much more of an oval-shaped orbit. If we look from this angle here, you can see when Earth is here, this is the closest point to the sun, roughly. But when it's over here, you can see it's a little further away. That's where it gets colder. So it's still looping around. Okay, so to support that eccentric orbit, maybe we need 2.15 luminosity of sun. Okay, oh, there you go. It's a bit of temperature there. We still need a bit more. Okay, so let's go to 2.2. Just a tad more. Okay, go to this Earth. And there you are. Okay, so it's in the positives. Still a little cold, but yeah, it's probably enough to get the conditions just a little colder than it is nowadays. So 2.25. That should hopefully give what we need. So it's in the positive temperatures. Goes up to 5. No, I think you still need a bit more just to support that orbit. So let's go to 2.3 suns. Okay, 2.3. Okay, it's going to around 6. Okay, I think 2.4. Let's just go straight to 2.4. So we want it between 5 and 10 consistently. And that appears to be roughly where we want it. Look, it goes from about 7 up to about 10. There you go. Okay, so for the Earth to be in the orbit of Mars, you need about 2.4 suns of luminosity. So here we are. So 2.4 L. There you are. Cool. Right, so that's the inner solar system done. But we could throw in Ceres, actually. Yeah, we'll throw Ceres in, but as we can see, if we look at the Earth closest to the Sun, it appears really being up now. 283 in the orbit of Mercury. Venus, 138. The original Earth, 76. And obviously the new Mars, or the new Earth in the Mars's orbit at 2.4 luminosity of Sun. But we're now going to take a jump, probably. Remember, Mars is roughly about 1.5 AU, isn't it? So yeah, 1.5. If we take a jump to Ceres, that's probably coming up to about 3 AU or 2.77 AU. Okay, so again, we're going to need probably a dramatic, almost a double here. So we're going from Ceres. So Earth in the orbit of Ceres. Okay, there you go. So this is obviously going to freeze over quick. So what we need to do here is the Sun. I'm assuming we're going to need at least 4 minimal to get this in here. So there we go, Earth. Let's see. So 4 luminosity of Sun, and it's not enough. No, you need more. Once you get past the orbit of Mars, that's where you really need the big numbers. So I'm gonna double it to 8. I'm not. Is this too much or? Oh no! Okay, maybe we've just snapped. Maybe we just snapped on it straight up. Okay, so let's watch. So it goes about, all the way down to about 7. Goes up to okay, so it gets a little warmer. But again, Ceres has that sort of elongated orbit. But I reckon we could probably decrease a bit. So I'm gonna go to 7.6. Okay, let's watch now. Okay, so it goes all the way down to around 5, 4. Okay, so it goes to 5. 5 and 10 is our target. Okay, so it doesn't hit 10 anymore. So they're the numbers we kind of want to see. So 7.65. And back to the Earth. Okay, so it goes all the way down to 5, 4, 3. Okay, now so it's still going a little too cold for my liking. We want it to be in that sort of range. 7.75. Okay, right, let's watch now. That should be roughly where we want. So it goes down to 4, 5, 6, 7, 8, 9, 10. It goes into 10. Okay. I think just to keep it in between 5 and 10, we're going to go to about 7.8. Just a tad more, just a little more. It makes all the difference, though. 8, 9, 10. It goes up to the mid-10s, all the way down to about 5, 4. Okay, there you go. I'd say, it's still... Look at the seasons changing, though. Obviously, because of the orbit change. It does get a little cold, but again, at the end of the day, the average is still roughly where it's sitting. So although the seasons may be different, overall, the planet should still be able to host the life it has today. Maybe, obviously, be a little colder in the north and southern regions. But, I mean, for the majority, it should be fairly okay. So, yeah, it goes up to about 10-ish. Goes all the way down to... Yeah, it doesn't even go below 5. So it's in between 5 and 10. It doesn't go to 4. It doesn't go to 11. That is our target. So, yeah. So we can happily say with this Earth in the orbit of Ceres, so we need about 7.8 luminosity of Sun. So we can see that's a huge jump from the orbit of Mars. So 7.8 L. Like that. Okay. Now, the outer solar system. So, Jupiter. That's roughly 5 AU away. So we're taking the jump from 2.77 to about 5. 5.2, so this is going to be a big one. We're going to need a lot of luminosity. We're probably going to need at least 20 or 30 suns here. So there you go. So as we can see, the zone is out, and we can actually use the zone to our advantage here to get a rough estimate. So, Sun. I'm going to immediately estimate, I don't know, 30 at the lowest, and then if we look here. So we're in the green zone. Okay, that's a good start. Right, so press play. So the inner solar system's all going to be completely out of it now. It's way too hot there. So, Earth in the orbit of Jupiter. It's getting a little too hot. Okay, we've overdone it. We have overdone it. Okay, so we actually need to go back to the Sun here. So we need to go from 30. Let's go to 25. That'll be quite a substantial decrease. Okay. Alright, let's see. 5, 4, 3, 2, 1. No, it's too cold. Too much. Okay, so we need to go in between 25 and 30. So we're going to go to 27.5, roughly in the middle. There you go. So let's watch now. And that's how the sun's gone blue as well. That's pretty cool. Right, okay, so 6, 7, 8, 9, 10. And it's cooling down again. Okay. 5, 4, 3, 2. Okay. So it's just a little on the colder side. So we're going to go to 27.8. It's just a bit more. Okay, let's see how that changes. The further away we get, the harder it's going to be to sort of get it exactly where we want. But okay, so 4, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I still think slightly on the colder end of the spectrum. So we're going to go up to about 20. We're going to go to 28 luminosity of Sun now. Back to Earth. That should be roughly where we want him now. So 10, 11. It goes a little higher in 11, and it's still on the colder side. Okay, just a tad more. 28.25. Okay. So it goes down. Doesn't go to 3 anymore, and it's going above 10 still. Yeah, okay. So I'm going to roughly say... So, what's it now? So it's about 20... So 28.2. So we'll put it roughly at 28.2. That's roughly where you want it. So 28.2 on the warmer side for occasion, but it does also get colder. So the seasons are a little more up and down. But there you go. Roughly, that's where you want to roughly be sitting. So you can see the average is changing up and down, but it's just due to the orbit. So to get it exactly perfect, you'd need all the little minor numbers in between the points, the decimal points, to really get it. But there you go. So 28.2L. So you can see that as an enormous jump in the outer solar system. So we've gone from 7.8 in the orbit of Ceres to 28.2 in the orbit of Jupiter. But now we're taking an even bigger jump, because if we look here, Jupiter's year is 11.9 years roughly. We take a jump to Saturn, 29.6 years. So again, that's a bigger jump. We're now almost at 10 AU now. So this is where the numbers are going to start getting big, because Saturn's roughly almost double Jupiter, so... And it's only going to double up from here on out, so there we go. So Earth placed in. There you go. So this is also going to freeze up real fast, so... I mean, I'm going to immediately take a gamble and just double this straight up to 56.5. There we go. So that's put this Earth, hopefully... Oh, it's still in the blue, It's still getting too cold. It's not enough. It is not enough. Okay, so... We need even more than double luminosity. Look at the temperature of the sun now. Oh, it's getting hot. So, we're going to go up to 60 suns. Orbit of Earth. Still getting too cold around the Saturn distance. Okay. 70. Just a big jumps. It's warming up. Okay, let's let time play out, because we are further. So, okay, there you go. Oh, no. And then again, Saturn's orbit is more eccentric as well. So... 80? Surely 80. Come on. Okay. Remember, it's still getting too cold. Look, it does really decrease in that further part in its orbit, but then it should warm up as it slowly approaches the sun again. So does it go into positive temperatures? It does. Still not even going into 1 degree centigrade, so we still need more. I mean, oh dear. That's the Mercury one, isn't it? Oh, Mercury. Haha. Okay. But yes, let's go to 87. And then back to this Earth. Okay, so no, it's still just not liking it. Still not enough to really give it the kick it needs. So let's go. So it does go into the positives, but it's just not enough to hold it consistently. We want it to always be above 0, no matter what. 92. Okay, 92, yeah. Okay. Still getting a little cold. Still, See, the temperature range is different here, so it's a little hard to sort of... 90... what am I talking about? 95. Then to Saturn. There we go. So it's still going in the minuses. That's not really what we want, but it's only minuses briefly, is it, in its orbit? But again, the seasons are still going up to around 12. So I think maybe just a little more, just to try and keep it out of the minuses completely. Let's go to 96. That should just give it a little extra luminosity kick it needs, hopefully. So it goes up to 13. It goes into the minuses very briefly, but I'm gonna say that is roughly where you want it. So 96. I mean, we could go 96. Try 96.5. So halfway in between, just a little more. Okay, so it goes up to 14. It goes all the way down to just under 1, very, very briefly. But I think that's roughly where we want to be. So I'm going to say about 96.5 as a rough estimate. So 96.5 L. There you are. Okay, so from Jupiter to Saturn, 28 to 96. That's pretty much tripled. So, whew, pretty wild stuff there. Right, so into the depths now. Into the unknown regions. Uranus. So, I mean, this is going to be... If Jupiter's gone from almost triple we're going to need probably almost quadruple here, I reckon. So I'm going to immediately say from 96.5, I reckon I'm going to need at least, so back to the sun here, I reckon I'm going to at least need, so double it, 190, I'm going to say probably around 280 maybe. Let's start with 280, see where we end up. It's in the blue, okay. Oh, it's immediately too cold. Look at that. Oh my god, okay. Yeah, that's not looking good. But if we go back to Saturn's orbit, how does Saturn actually cope in this? Yeah, even the orbit of Saturn immediately up into 90 degrees. So that's just... Oh. Okay. Jupiter's orbit. 206 degrees. So yeah, there's just nothing there left now. Okay. And this will kind of simulate how the planets will survive in the red giant phase of the sun. So although the sun's not getting any bigger, we are just making it a lot brighter. Okay, 280. Okay, let's go straight to 400. I mean, no messing around now. 400. Press play. Oh. Okay, so it goes into minuses 1. Okay, -1. Now, Uranus's orbit takes some bit of time. So it goes up to 4, 5, 6, 7, 8, 9, 10, 11. So you can see the orbit's really... Because of the orbit eccentricity. Look at that. So it goes to -1. But again, I think that's roughly sitting quite nicely in its orbit. I mean, it's got a nice range of temperatures. It's got a summer and a winter. Quite a little warmer summer, a little colder winter. But, I mean, yeah. I mean, let's actually look at the surface grid through the seasons here. So we can see, as the temperatures at its hottest, it goes up to about 55. But then it cools all the way down in the winter. See, look at how that's changing the season. So it goes to, in the winter it's very cold, but then in the summer it goes up to 55 in the coldest. But then all the way back to the winter it goes all the way down to minus 128. But if we look roughly on the equator area, so point at the Africa area here, it's 25, 24, 23, 20, go all the way down. And that slowly cools down to about into the minuses. So if you're sitting roughly, as long as you're not at the North or South Pole, you should be alright. It's just the North and South Poles. They get the real beat of the sun in the season changes. Look, you see the South Pole, that goes into the hot. And it will slowly cool down into the cold. So stay away from the North and South Pole and you'll be okay. So there you go. But yeah, we don't want to make the hotter areas any quicker or any hotter. I mean, Earth can normally... some of the temperatures on Earth this year have been recorded into the 40s. So, I mean, this is going up to the... Yeah, this is going up to almost 50. So, we can't really push the sun any more than that. So, I'm going to say for Uranus's orbit... So, what is this? So, you roughly want to be around 400. But remember, these are just sort of rough numbers. I mean, the exact values will be a little different. But, yeah, that's roughly where we want to be. So, 96.5 at Saturn to 400 at Uranus. So, that is a quadruple. Over quadruple. So, for Neptune now. So, it goes from 19.2 AU all the way to about 30 now. So, the final planet. Now, take a guess where you think this is. This is going to be at least 8. This must be at least 900. It's got to be. So, there you go. There's Earth. Now, Sun. I'm just going to straight up double this up and just see 800. You know, I'm going to go even wilder. 850. Play. Earth, how are we doing? Getting cold immediately in the orbit of Neptune. Oh. Oh. It doesn't get any temperature. It is too much. Too much. Okay, so. Back to the sun. 900. So let's check. Keep people on their hats. So we're in the green now. Okay. Looks like we should be getting some temperature here. No. Oh, no. It's going down again. Let's see how it turns out. Okay, so -1. Okay. There's some temperature there. Goes into temperature very briefly. So again, we need more than that. Back to the sun. Oh, dear. Was that the Jupiter one? Oh. Oh, my God. All right. Let's go. Sun. Go on the sun. Oi. Right. Sun. Okay, so. I don't think we can go any higher than 1,000 on this. So, I mean, hopefully we can just sneak Neptune's orbit in. So, here we are. Okay, 950. Oh, 2, 1. Okay, so it goes into the minuses. Then it warms up. Okay. Because Neptune's orbit seems to be more consistent than Uranus's. Okay, interesting. So, 975. That should hopefully, roughly kick it where we need to be. Okay, so it goes down to minus, just before, and it goes up to about, okay, so it's in between about minus 0.5 and 9 degrees. So, just a bit more, just a tad more on it. Oh dear, that's the original Earth, sir. Oh, that's the Mercury Earth. 980. Play. Neptune orbit. Okay, so it goes up to 9, cools down to about... Well, that stays in the positives now. Okay. Well, it gets a little colder there, but remember, Neptune's orbit is big. So, okay. I think just a tad more then. 985. I guess that's a 5 extra luminosity there. Okay. How's Uranus's orbit doing here? Is this 70 degrees? Yeah, ooh. So the zone is past that area now. Okay, we can look on Neptune Earth, please. Okay. So really, you really have to kick the values up far to really get the where you want. Okay, 990. Done. Okay. So staying in the okay, we're in the positives. It goes up to 9. Okay. Okay, just maybe a little bit more, just to really keep it in the 995. And I think 1,000 is the absolute limits. We should just be able to sneak this in. Goes up to 10, okay. Goes down to a 3, 4, 5, 6, 7, 8, 9, okay. Goes a little colder there, but I think that is it. I want to say that's roughly where we want to be. So Earth. So this is at 900. Whoa, 995 luminosity of sun. So 995 L. There you go. So if we look back at the original Earth here. So if the Hattle of Neptune, the original Earth will be at 1200 degrees for Earth around Neptune to be habitable. So there you are. Now I'm going to continue to Pluto. I think this is the Pluto. We probably won't be able to go any further because the sun won't go any more luminous. It's limited at 1,000, I believe. So. Oh, no, they were talking about luminosity. Oh, no, we should be fine, actually. Not what I was saying. It's atmosphere. I was thinking of atmosphere pressure. No, we'll be fine. Okay, so we can keep going. So Earth in the orbit of Pluto now. So let's see where this roughly starts off. So remember, Pluto's orbit does go into the Neptune distances, but then it goes really far out. As you can see, this is going to be very difficult because Pluto's orbit is a lot more eccentric than Neptune's. So it goes up to positives, but then it just freezes out again. So I don't think it's actually theoretically possible for Earth to be habitable in the orbit of Pluto. I think it's just too much of a season change between summer and winter for it to look. It goes from -59, warms up to +5 to -50. That is not going to work. But I mean, to get the ideal range, I mean, 1,200 suns. And even at the furthest point, it's still just nowhere near. I think Pluto's orbit. I'm going to put Pluto as just not possible. I think there's no way. There's no way that would work. Because if I make the sun too bright, then it will just be too hot in the closer point. So it goes up to 20, but that's going to be a challenge to do. I mean, it needs to stay warm in the colder seasons. So 1,500. Okay, so even at the... This is still just too much. -30, unless you want to have a really cold winter. Then in the summer, it goes up to 41. See, there's no way. But, I mean, it has a good taste of both here. It goes from about -30 to +40. So, I mean, you probably could lower it just to keep it in the range of the -30 to +30. Let's go to 1450. Watch it now. Okay, so it goes all the way down to -32, 33. Okay, then it warms up to +39. So, I mean, Pluto, this is a very, very wild result. But, you know, you can't really gauge it because of the orbit. So, 1450 L at the orbit of Pluto. But that is a very, very wonky answer, so don't really take that. That's purely for comparison purposes, but that's not really what we want. And then I don't think we can really go much further than Pluto because all the orbits are just wild at that point. I mean, Eris's orbit, that's a no-go. We could try Makemake orbit. So if we look here, Makemake, so... Or make, however you want to say it. So... Base colour. I don't want base colour. No, I want interface, that's it. So, that orbit should hopefully work a little better than Pluto's. Possibly. I mean, we could look at Orcus as well. That's Orcus. Orcus may have a good orbit to do, actually. Possibly, could we use Orcus? Mackay. See that they got really. Ooh. We also got this one as well. Now that orbit could be. I'm gonna go with that one. So, Quara. I'm not even gonna try. So, replace. Now, again, this one is quite similar to Pluto. So, I mean, maybe it will just work pretty. So let's just see how Earth. So this is still the one for what we gave for Pluto here. So, how's this gonna work? Again, I think the dwarf planets are all just too the eccentric for it to really work. But you can see this one is still too cold. But the temperature doesn't change as much. So it is further out than Pluto, though, because you can see it's not getting any temperature at all here. So what we can do is go to 1600. Go over here. Yeah, that's a big change. No, it's still not enough. Okay, back to the sun. Oh dear. Those inner objects are just not having it. 1800. No, not 180. Oh, that'll cool them down a bit, but there you go. Oh, look at this temperature of the sun now. Oh, right. So, any changes here? Can it go in the positives at all? Yes, it is going in the positives, but it immediately gets cold again. So, back to the sun. 1900. Okay, so there's Earth there. Right, oh, it's still not really where we want him. That's a challenge. That's a difficult. Right. 2000. So we're leaving the Pluto one behind now. Okay. So if I actually go to Pluto, so there's Pluto there. How does that actually work with this one? See, look, that's just too much. See, 66. Then it cools down to what? That's just not what you want. So, anyways, back to this one. There we go, Earth. Okay, alright, so let's see how this works. So it goes into just under minus, okay. And it goes up to 4 for its orbit still change. Okay. Yeah, there's a lot better results than Pluto. That is a way better example to use than Pluto, actually. Very, very nice. Okay, 2100. And back to Earth. Okay, keep an eye on that. Yeah, okay. Yeah, I'm gonna settle with that. 2100. Oh, very nice. Very good results from that guy. But I don't think any. They're all roughly sitting in the same sort of orbital plane, all those guys. So you're roughly going to be looking in between the value of Pluto. So 1450 and 2100 for most dwarf planets. In there, obviously Eris's orbit, that one is just too eccentric for it to work at all. Sedna, we're not even going to go there. And then, yeah, anything further out. It looks like something actually got ejected here. But, yeah. That is my results for this little experiment, guys. So going all the way back to the beginning now. So, for Earth to be habitable in Mercury's orbit, you need 0.15 luminosity. For Venus, you need 0.55. Obviously, the original Earth is just 1. Mars, 2.4 L. Ceres, 7.8. Jupiter, 28.2. Saturn, 96.5. Uranus, 400. And then Neptune, 995. And that's roughly where the planet results. And then we had Pluto at 1450, and then the one we just did there at 2100. So you could cover mostly all the dwarf planets in between 1450 and 2100. So there we are. What do you think of that? Now, that was an interesting experiment. I hope you guys enjoyed it. So yeah, if you did, let me know down below in the comments. Make sure to press that like button. Let's actually see if we can go for. Let's try and go for 90 likes on today's video, guys. So yeah, if you haven't already, press that like button as well. Subscribe if you haven't already. Helps on the journey to 30,000 subscribers as well before midway through January. And yeah, guys, I really hope you've enjoyed this. This was a good one. This was a really fun one to do, actually. So I really hope you enjoyed it. If you've got any more experiments we could do, maybe we could do this with Venus or Mars as well. let me know down below in the comments. But with that all said and done, guys, thank you very much for watching, and I'll see you in the next video. Goodbye.